This video will explain it all. In high school chemistry, the magical metal that reacts with everything, sodium. Before we fully understand it, don't rush to add sodium. Let's get started. Okay, so the first question, and the one that's most easily confused, is this. When sodium reacts with oxygen at room temperature, does it form sodium peroxide or sodium oxide? Pay attention, it's sodium oxide. It only forms sodium peroxide under heating or ignition conditions. One is a white solid and the other is a pale yellow solid. How do you remember this? Don't just memorize it. Pay attention, you need to remember it through the phenomena. At room temperature, if you cut sodium, its surface will tarnish. That's it reacting with oxygen. But notice it's still white. So at room temperature, it forms white sodium oxide. But when sodium burns, it has a yellow flame, forming a pale yellow solid. That is sodium peroxide. So since sodium can react with oxygen, it means it has reducing properties, right? Then it can certainly react with the corresponding chlorine gas. The condition is just ignition, forming the corresponding sodium chloride. Now, sodium's reducing property isn't just present, it's very strong. So strong that even with weak oxidizing agents like hydrogen gas and elemental sulfur, it will still react to form sodium hydride and sodium sulfide. Next, have you seen videos like this? Sodium is thrown into a pond and jumps 4 meters high. It's very dangerous. This is the reaction of sodium and water, a vigorous reaction forming sodium hydroxide and hydrogen gas. This reaction is the main focus of today's lesson. Many exam questions cover it. For example, these two questions. First, what are the products when sodium reacts with a saturated sodium chloride solution? Second, what are the products of the reaction between sodium and an ammonium chloride solution? Okay, let's break it down. First, the reaction of sodium and water consumes water. That's the first point. Second, it produces hydrogen gas. Third, it produces sodium hydroxide. And fourth, note that this reaction releases heat. Then let's determine what's in these two solutions. First, there's definitely water, right? There are also sodium ions, chloride ions, and ammonium ions. But I found that none of these ions will react with sodium because they are all in their lowest oxidation state. They can't be reduced further. So there's no issue. It's just a simple reaction with water. But wait, in the first question, I saw the word saturated and I feel something is off. Saturated sodium chloride means that it's in a state where no more can be dissolved. And with sodium, as soon as it reacts with even a little bit of water, the sodium chloride will precipitate. So the products at this point will include some precipitated sodium chloride crystals. So what if it reacts with an ammonium chloride solution? Note that it's an unsaturated solution, so we don't have the previous problem. The key is to look at the ammonium ion, since the reaction produces sodium hydroxide, and the reaction also releases heat. The temperature will rise. This will promote the combination of ammonium ions and hydroxide ions, forming the corresponding ammonia gas and water. Okay, so that's those two questions. Now, what if we level up the questions? The previous ones were simpler, as those ions don't react with sodium. But what if I make it so the ions can react with sodium? For example, hydrogen ions and copper ions are both ions with oxidizing properties. So I'll ask you to determine the products of the reaction between sodium and copper sulfate solution and between sodium and hydrochloric acid solution. Okay, remember the order here. Hydrogen ions are greater than water, which is greater than copper ions. What does that mean? You'll understand after I explain. First, the reaction of sodium and copper sulfate solution. If we use our middle school knowledge, this should be a displacement reaction, where the active metal, sodium, displaces the less active metal, copper, right? Forming elemental copper and also sodium sulfate. But pay attention, there's a large amount of water in the solution at this time. Water takes priority over copper ions. So as soon as the sodium enters the solution, before it even sees the copper ions, it gets surrounded by a bunch of water reacting to form sodium hydroxide and hydrogen gas. And subsequently, the sodium hydroxide will then combine with the copper ions from the copper sulfate, forming the corresponding copper hydroxide, which is a precipitate. Okay, some of you are very smart. Since the presence of water prevents the displacement of metal ions, then wouldn't removing the water solve it? For example, under high temperature molten conditions, sodium can then displace the titanium ions in titanium chloride, forming the corresponding titanium metal and sodium chloride. Okay, and that solves it. So what about the reaction of sodium and hydrochloric acid? Note that there are two situations. First is concentrated hydrochloric acid. Since I just said hydrogen ions react before water and concentrated hydrochloric acid has many hydrogen ions, sodium will only react with the hydrogen ions, not water. What if we use dilute hydrochloric acid? Pay attention, hydrogen ions are fewer, so it reacts with hydrogen ions first. If there is extra sodium, it then reacts with water. Okay, so at this point, are we done with all the test questions for this equation? Not yet, not yet. There's another important test point here, which is the phenomenon of this reaction. This is also a key point. It's called float, melt, dart, hiss, and red. If you understand this, you'll understand all the properties of this substance. First, why does sodium float on water? Because the density of sodium is less than water. And why does it melt into a small ball? Because first, this reaction is exothermic. Second, sodium's melting point is very low, only 97 degrees, so it melts immediately. Darting happens because sodium reacts with water to produce hydrogen gas, which pushes the sodium like a rocket booster. The hiss shows the reaction is vigorous, meaning sodium is a strong reducing agent. The red color comes from phenolphthalein added to the water, which turns red in a base. Besides this, sodium has two more physical properties. First, it is a silvery white solid with a soft texture. Second, it has good thermal and electrical conductivity. Now that you know the properties of sodium, let me ask you, since sodium has so many properties, how is it stored? Storing it in a container is not an option because there is oxygen in the container, so it must be stored in a liquid to keep it away from oxygen. I'll give you a few options to choose from. A. Kerosene. B. Carbon tetrachloride. C. Ethanol. Which one should it be stored in? The answer is A. Kerosene. Why? First, we can rule out ethanol because like water, the hydrogen in ethanol can be reduced by sodium, causing a reaction, so it's definitely not suitable. Second, why not carbon tetrachloride? Because the density of carbon tetrachloride is greater than that of sodium, so the sodium will still float on the surface of the carbon tetrachloride. Once you open the bottle cap, it will still be oxidized by oxygen. As for kerosene, it neither reacts and its density is less than sodium's, so sodium can sink to the bottom of the kerosene, making it perfectly suitable. Okay, that's it. This covers the common knowledge points and test questions related to sodium.